Your journey with the QU Placer math test begins here, with the foundation of everything in mathematics, real numbers. Did you know that classifying numbers into natural, integers, rational, and irrational is the very first key to understanding algebra and beyond? In this lesson, we will lay the cornerstone upon which everything else will be built.
In the name of Allah, the most gracious, the most merciful, and may peace and blessings be upon the noblest of messengers. Today we're going to talk about the first lesson in first section, elementary algebra. This lesson is called real numbers. Of course, you remember some of real numbers or some of the sets of real numbers. Let's glance over some of the sets. You remember the natural number, which consists of 1, 2, 3, and so on. And if you added 0, you'll get the whole numbers. So the whole numbers consist of 0 and 1 and 2 and 3 and so on. And if you added the negative numbers, you'll get the integer numbers. So the integer number is consisting of the positive numbers and the negative numbers and 0. And if you added some of numbers that can be written in the fraction, this is called the rational numbers. So the rational numbers, you can write any number in the form of a over b, where a and b are integers and b doesn't equal to 0, like 2 over 3, like 3 over 4, and so on. And for decimal numbers, it should be terminating. What does it mean by terminating? Terminating means you can stop at a certain digit, like 3.4, you stop at 4. 2.361, so you stop at 1. So this is called terminating number. So this is a rational number. If it's not terminating or non-terminating, it should be repeating, like 9.45 repeating. On the other part, we have irrational numbers. And irrational numbers are the numbers that you can put it in the fraction a over b. So for example, the square root of 10. If you get square root of 10 on the calculator, you will get a non-terminating number. The square root of 2, for example. So here, if I wrote square root of 3, you'll get a non-terminating number, and non-repeating, by the way, non-repeating, because if it's repeating, it will be rational number. But this number is not repeating, and it's non-terminating. Like square root of 2, this is a rational number because you have a number that is not repeating and it's non-terminating. And square root of 10, and so on. And take care that pi is a rational number because it's non-terminating. I know that you know that it's 3.14, but this is approximating. Approximately is equal to 3.14, but it's non-terminating. Let's take an example. In the set a equals blah blah blah, which elements are integers? Let's remind you of the integer numbers. The integer numbers is equal to 0 in the middle, 1, 2, 3, and so on, negative 1, negative 2, negative 3, and so on. So let's take the numbers in the set. Negative 9 is already here. If you complete the numbers, you will get negative 9. So negative 9, yeah, negative 9 is an integer. But negative 7 over 2, not, because the fraction and the denominator is not 1. The decimal is not in the integer numbers. Negative square root of 5, you will get it on the calculator. You'll not get a number in the integer number. The negative square root of 5 is not. And negative 1 is already here. 0 is already here. And 3 is already in the integer numbers. 10 over 3, you can put it in the integer numbers. 5 point, it's not. And 8 is already here because if you completed the numbers, you'll get 8. So again, you have negative 9, negative 1, and 0, and 3, and 8. So this is the answer. Here in this example, from the set, list all the elements that are rational numbers. Again, the rational numbers that you can put it in the form a over b. All right? Or if it's decimal, it should be terminating. I mean, it ends So negative 12 is a rational number because negative 12 you can put it in the form a over b, negative 12 over 1, negative 11 over 2, it's in the rational numbers. But negative square root of 13, if you got it on the calculator, you'll get a number which is non-terminating. It will not end. So this is wrong. Negative 2.2 is a rational number, 0. By the way, the rational numbers, if you get a number like integer numbers or whole numbers, these are all subset of the rational numbers. So any number which is integer number, it should be rational numbers, by the way. Square root of 2, it's not, because it's an irrational number. 8 over 3, that's right. And this number is decimal, but it's terminating. It's terminating, I mean that it stops at 2. So this is rational numbers. So negative 12 and negative 11 over 2, negative 2.2, 0, 8 over 3. So this is the answer. Which subset of real numbers contains 3 square root of 2 plus 1? I think you remember that square root of 2 is not, or is irrational number. So if you get this expression, 3 square root of 2 plus 1 on the calculator, you will get a non-terminating number. So it's irrational numbers. The sum of two negative numbers is always a. Let's complete that sentence. Let's take an example. If I have negative 3 plus negative 4, negative 1 plus negative 5, negative 6 plus negative 3, all of these are negative because he says that the sum means plus. The sum of negative numbers. So the first number is negative and the second number is negative also. How can I get the answer? Negative 3 plus negative 4 is equal to negative 7. So the answer is negative. Negative 1 plus negative 5 is equal to negative 6. So the answer is negative. Negative 6 plus negative 3 is equal to negative 9. So the answer is always negative. So the answer here, a negative number. Here, if I have numbers and I want to do the operations like 3 plus 2 times 4 and then divided by 2 and then minus 1 and so on. What is the operation that I can do first? Should I add first because addition in the first, or multiplication or division? Here is the rule. The rule is PEMDAS, which is please excuse my dear Aunt Sally. P stands for parentheses, or parentheses here in the plural form, and E is exponents, and MD multiply and divide from left to right. So if you have the multiplication first on the left, you will do the multiplication. If you have the division first on the left, you will do the division, and so on. And AS, which is add or subtract from left to right. So here the first thing is the parentheses. Do you have the parentheses here? You don't have. Parentheses means brackets. So you don't have any parentheses here, right? So let's go to the next step, which is exponents. Do you have any exponents? You don't have any exponents. MD, multiply or divide. Yeah, you have. You have the multiplication on the left, so you have to do the operation of the multiplication. So here you will keep 3 plus, and 2 times 4 is 8, and then complete the sentence, divided by 2 minus 1. Again, what is the priority here? The priority is for division, because multiply and divide from left to right. All right, so you have to divide 8 by 2. So 8 divided by 2 is 4, so keep 3, so 3 plus 4 minus 1, and then you just have addition and subtraction, so you can do it at once. So 3 plus 4 is 7, 7 minus 1 is 6. All right. By the way, from now on in this lesson, you can do the math by the calculator. You can solve the problems by the calculator, but it's better to know how to solve the problem, because later you will find some problems like or the problems that have variables like x, y, something that you can't do by the calculator. So you have to have an idea about that, even if you know how to write it or to answer it by the calculator. Here's the expression 8 plus 16 divided by 4 times 5 minus 3. You remember the rule? The rule is please excuse my dear Aunt Sally. And the first letter is P, the parentheses. You don't have any parentheses, so let's move on to the next step, which is exponents. You don't have any exponents here. M and D, multiplication and division from left to right. Do you have any multiplication or division here? Yeah, from left to right, you'll get 16 divided by 4. So you have to get 16 divided by 4 first and keep the left are they are. So 8 plus, and 16 divided by 4 is 4, times 5 minus 3. All right. Do you have any multiplication or division here? Yeah, you have. You have 4 times 5. So keep 8 plus, and 4 times 5 is 20, and then minus 3. Now you have A and S, addition and subtraction, you can do at once. 8 plus 20, which is 28, minus 3 is 25. So the answer is 25. Evaluate the expression 5 times 1 minus 1 over 5 minus 2 times 2 minus 1 over 5. Again, the rule is please excuse my dear Aunt Sally. Do you have any parentheses here? Yeah, you have 1 minus 1 over 5 and 2 minus 1 over 2. So let's get 1 minus 1 over 5 first. Here's 1 minus 1 over 5. 1 minus 1 over 5. Before adding or subtracting the fractions, you have to make sure that the denominators are the same. So here, 1 divided by 1. So the denominators are not the same. The denominators are different. So you can change 1 over 1 to be 5 over 5. The same answer, 5 over 5 is 1. So it's equal to 5 over 5 minus 1 over 5. Or you can do the scissors. But here it's easy to make it 5 over 5. So the denominator is 5, and 5 minus 1 is 4. So here is the answer, is 4 over 5. For the next parentheses, 2 minus 1 over 2. Two minus 1 over 2. The denominator here is 1, so you can change 2 over 1 to be 4 over 2 to be the same denominator. So 4 over 2 minus 1 over 2. 4 over 2 is the same, is 2. So the answer is, here you have the denominator is 2, and 4 minus 1 is 3. So the answer of this parenthesis is 3 over 2. So let's substitute this answer in the expression. So now you have you have 5 times, and 1 minus 1 over 5, which is 4 over 5, and then minus 2 times 2 minus 1 over 2, which is 3 over 2. All right, now we have multiplication, and then subtraction, and then multiplication, but the multiplication has the priority. So 5 times 4 over 1, 5 here means 5 over 1. 5 times 4 is 20, divided by 5, which is 4, minus 2 times 3 over 2. Now we have subtraction and multiplication, but the multiplication has the priority. So you have to do the multiplication first. So it's 4 minus, and 2 times 3 is 6. 6 divided by 2 is 3. So 4 is equal to 4 minus 3, which is equal to 1. All right, so the answer is 1. Again, the rule is, please excuse my dear Aunt Sally. The first Lateral stands for parentheses. Do you have the parentheses here? Yeah. 4, here is the parentheses, 4 to the power of 2 minus 2. So this is the first parenthesis. I know that you have another parenthesis, but this is the inside. So you have to get the parentheses inside and then get the parentheses outside. All right, so 4 to the power of 2. So let's keep all they are. So here 4 minus 5 times, dot here means times, and then the bracket 5 minus, and 4 to the power of 2, which is 16. 16 minus 2 is 14, so here's 14. We still the parentheses. We didn't get rid of the parentheses, so you have to get the answer of the parentheses. Here the parentheses 5 minus 14, which is negative 9. All right, so 4 minus 5 times negative 9. Now, the next step, do you have any exponent? You don't have any exponent here. MD, multiplication or division. Yeah, you have the multiplication, so you have to do the multiplication first. So it's equal to 4 minus 5 times negative 9, which is negative 45. Negative, negative means plus. So here's 4 plus 45, which is 49. Evaluate the absolute value of negative 6 minus 2 minus the absolute value of 1 minus 12. Here you can get the absolute value. The absolute value is like bracket or parentheses, so you have to get the parentheses first, which is the absolute value here. So negative 6 minus 2, which is the absolute value of negative 8, and the absolute value of negative 8 is equal to 8, right? And here, the absolute value of 1 minus 12, which is the absolute value of negative 11, which is equal to 11. So again, if you write the answer, if you write the expression, it will be 8 minus, and here the absolute value of negative 11, which is 11. So 8 minus 11 is equal to negative 3. So the answer is negative 3. Here, let's write the rule again. Please excuse my dear Aunt Sally. Parentheses, you don't have any parentheses here. And the exponents, yeah, you have exponents. You have 2 to the power of 3, and negative is outside the parentheses, or I mean, it's outside the exponent. But here's the problem. Here is the problem. You have 1 over 3 to the power of negative 2. But first, let's take, or let's get 2 to the power of 3. 2 to the power of 3 means 2 times 2, so it's equal to negative 8 plus. Here, just to remind you of, if you have a negative exponent, you can write it as positive exponent, but if you change the base to be up, so 1 over 3 to the power of negative 2, it will be 3 to the power of 2. So here plus 3 to the power of 2. You changed the sign of the power, or change of the sign of the exponent. So it's equal to negative 8 plus, and 3 over 2, 3 to the power of 2, which is 3 times 3 means 9. Negative 8 plus 9 is equal to 1. Simplify 5 square root of 27 minus 6 square root of 3. Again, you can get the answer by the calculator, but let's try how to get the answer step by step. Here, these are not like terms or unlike terms, because you have square root of 3 here, and here you have square root of 27, so they are not like. So if you change it a little bit, it will be like. How? The square root of 27 is equal to the square root of, just try to get the product of two numbers, and one of them has a square root, like 9 times 3. 9 times 3 is equal to 27, and you have a square root of 9. So the square root of 9 is 3, so it's equal to 3 outside, and the square root of 3 inside the square root. So again, if you changed, if you rewrite the expression, it will be 5 times the square root of 27, which is 3 square root of 3, and then minus 6 square root of 3 is equal to 5 times 3 is 15. 15 square root of 3 minus 6 square root of 3. Now you can subtract the numbers, which is 15 minus 6, and keep square root of 3 as it is. So 15 minus 6 is 9, so 9 square root of 3. So the answer is 9 square root of 3. Now, how to rationalize the denominator? What does it mean by rationalize the denominator? Means you have in the denominator a square root, or a root, I mean, like 1 over square root of 2, for example. And this denominator maybe is just one single root, like this, 1 over square root of 2. Or sometimes it has a binomial, which one of them is, or one of them has a square root, like 3 over 2 minus square root of 5, for example. So this, in the denominator here, we have 2 minus square root of 5, which is binomial, means the two terms, and one of them is irrational number. So our issue is how to convert from the irrational number, like square root of 2, or 2 minus square root of 5, to rational number. Here, if you have just one single root, you multiply by this root up and down in the numerator and in the denominator. Here, times square root of 2 and divided by 2 square root of 2. But here you have to multiply by the conjugate. What is the conjugate of the denominator? Which is 2 minus square root of 5. The conjugate means the same denominator, but change the sign. And instead of writing minus, you write plus. So multiply by 2 plus square root of 5. And here multiply by 2 plus square root of 5 and complete. Let's take an example. Here, rationalize the denominator 5 over square root of 7. 5 over square root of 7. Here it's just single root, right? So you multiply by square root of 7 up and down. Is equal to 5 times square root of 7, which is 5 square root of 7. And square root of 7 times square root of 7 is 7. And this is why we multiply by a root, or by the same root, to get rid of the symbol of the root. So the answer is 5 square root of 7 divided by 7. All right. And here rationalize the denominator, 5 over 5, I mean 2 over 5 minus square root of 2. Here's 2 divided by 5 minus square root of 2. And because this denominator is a binomial, so you multiply by the conjugate. What is the conjugate of 5 minus square root of 2? It's the same, but you will change the sign. And instead of minus, you'll write plus. So times 5 plus square root of 2, and the same here, 5 plus square root of 2. And then get the answer. 2 times 5 plus square root of 2, we can just keep it now. 2 times 5 plus square root of 2 divided by, here how to multiply the number by its conjugate. You'll just multiply the first number, or the first term, by the first term, and the second term by the second term. 5 times 5 is 25, and then negative square root of 2 times positive square root of 2 is minus. It's always minus here. It's always minus. And square root of 2 times square root of 2 is equal to 2. All right. So let's complete. 25 minus 2 is 23. And if you look at the numerators here, you will find that he multiply the number outside the parentheses inside. So 2 times 5, and then 2 times square root of 2. 2 times 5 is 10, and then plus 2 times square root of 2, which is 2 square root of 2. So the answer is 10 plus square root of 2 divided by 23.